Welcome again, everyone. So in today's lesson, we focus on the combined gas law, which connects pressure, volume, and temperature when the amount of gas is constant. So by the end of this video, you'll be able to solve problems where pressure, volume, and temperature all change, and rearrange and apply the formula confidently. Solve example style questions step by step. Yeah. So the core concept for today's lesson is combined gas law, and the combined gas law formula that we use is P1 V1 over T1 is equal to P2 V2 over T2. So this is the combined, that's why we call it combined gas law formula, because as you can see, it's somehow like combined, is it Charles law and Boyle's law? Yeah, something like that. So we will be using that formula if you have been given pressure and volume, maybe temperature, and you need to find maybe volume 2. Yeah, just as in the example below that we are going to solve. Yeah, so the key points to know here is temperature must always be in Kelvin, just as I emphasized in most of the videos. Then volume and pressure are inversely proportional if T is constant. So volume and the pressure, they should be inversely proportional. That's why you can see even in the formula, pressure and volume, they are inversely proportional, and the volume and temperature, they should be what? Directly proportional to what? To each other. Yeah, so those are the key points that you should know. So let's look at this example. In this example, they are saying a gas occupies, we are saying a gas occupies 2 liters at 1 atm and 300 K, and it's not 1 liter atm, it's just 1 atm, which is 300 K is the temperature, which means this gas, we have been given the initial volume, the initial pressure, which is 1 atm, and also the initial temperature. Then if pressure is increased to 2 atm, which means we have been given P2 again, which is 2 atm, and temperature rises to 400 K, which means we have been given again what? Temperature 2. What is the new volume? So we use the same formula, we just make V2 the subject of the formula. So V2 is the one that we are looking for. So this is the formula that we are going to use, which is pressure 1 times volume 1 times T2 over T1 P2. So this is the formula we are going to use. So we just replace the values. What is P1? P1 is 1 atm. What is volume 1? Volume 1 is 2 liters. Then temperature 2 is 400 K. Then we just replace the values. So after replacing the values, so that's, there we go, that's the value we are having. So we just need to punch our calculator, which is 1 times 2, which is 2 again, the same 2 multiplied by what? By 400. What's the answer? 1.33, which is liter. So that's our volume 2. What can we notice from here? When we started, the volume was 2 liters. It has reduced to 1.33. Why has the volume decreased? Because the pressure increased faster than temperature. As you can see, pressure increased from 1 atm to what? To is it 2 atm? Yes, 2 atm. So we said earlier that pressure and volume are inversely proportional. So since the pressure increased from 1 atm to 2 atm, the volume, we're expecting the volume to decrease. And also we are saying the volume decreases because pressure increases faster than temperature. Yeah, so it increases faster than temperature, so that's why the volume has decreased. So let's go ahead and do example 2. So the second question is saying a 3 liter gas at 2 atm and 350 K is heated to 420 K with volume expanding to 4 liters. Find the final pressure. So we still use the same equation. Now we just make pressure 2 the subject of the formula. So that's the formula we are going to use, which is pressure 2 is equal to P1 V1 times T2 over T1 times volume 2. What's our pressure 1? Our pressure 1 is 2 atm times what is our volume 1? Volume 1 is 3 liters. What about temperature 2? Temperature 2 is 420 K. 420 over what is our temperature 1? Temperature 1 is 350. And what about volume 2? Volume 2 is 4 liters. So let's go ahead and punch it on the calculator there. What are we going to find? We are going to find that the answer is 1.8 atm. That's our final pressure. And also we can the statement there, which is pressure and volume, they are what? They are inversely proportional to each other. As you can see in this equation, when we are starting at the volume of 3 liters and it has increased to what? To 4 liters, which means we are expecting the pressure to what? To decrease, and that's why you have seen the pressure to what? To decrease, because we had an increase in what? In volume. So there's nothing difficult about combined gas law. You just need to use the formula and identify which one is the initial pressure, which one is the final volume, temperature, or pressure. So here is our last example. A gas at 15 atm and 2 liters is compressed to 1 liters at 2 atm. If initial temperature is 300 K, find the final temperature. Again, we just use the same formula. Now we make T2 the subject of the formula. And at the end, that's what we are going to have, P2 V2 T1 over P1 V1. Then we just replace the values there to get what? T2. What is our pressure 2? We see that it was 15 atm and it has been compressed to what? To 2 atm. So it's 2 times what about it? Volume. Volume 2 is 1 times what about temperature 1? Temperature 1 is 300 over pressure 1 is 15 times volume 1 is 2 liters. So let's go ahead and punch it on the calculator. We are going to see that it's not 15, it's 1.5, this one. Yeah, 1.5. So we are going to find that the answer that you are going to find is 600 over 3 down. 600 over 3, which is equal to 200 K. So our final temperature is going to be 200 K. So what has happened? Our initial temperature was 300 and the final is 200, which means temperature has what? Has reduced. And why has it reduced? So let's look at pressure. Pressure moved from 1.5 to 2 atm, which means pressure increased. Now, what's the relationship with pressure and temperature? So among the laws, we say temperature, volume and pressure are inversely proportional. Pressure and temperature and volume are inversely proportional. Then volume and temperature are directly proportional. Let's look at volume. Volume, the initial volume was what? 2 liters. And the final volume was what? 2 liters. Which means volume decreased. So this one, the law here doesn't apply. Yeah, maybe the thing it holds to what? To pressure. Now these laws they doesn't hold because temperature, like for example this one which is saying like volume and pressure inversely proportional if temperature is constant. Now here temperature is not what? It's not constant. Same applies to the previous examples. For the one that it says that direct or inversely proportional, one needs to be constant, and that's why you are seeing some laws are not what? Are not agreeing. Yeah. So what are the quick tips that you should know? Always convert temperature to Kelvin, check with quantity change and which one is constant. Yeah. Also rearrange formula depending on what is asked. Volume tends to increase if temperature rises or pressure falls. So try the practice problem that I'll put on the screen here. So try to solve these practice problems on your free time. So as usual, if you are new to the channel, consider subscribing so that the video can reach out to many people that may be in need of it, and also for you to receive more lesson videos. So thank you for watching and see you in the next video where we'll be talking about is it built on flow, and other lesson videos to finish up what gas law.